Okay, trigonometric functions of general angles. We've looked at trig functions in terms of sine and cosine and tangent using right triangles. But now let's look at terms of sine and cosine and tangent in terms of any angle. So suppose we started with our coordinate system, and I gave you a point, which we'll call xy, and I'll just put it over here, x, comma, y. Now, we could go ahead and draw this angle in, and our angle always comes from the origin and ends at our point. The rotation of our angle would be right here, and this would be theta. Now, our angle here really helps us form a right triangle. This right triangle you get from always going from your point to the x-axis. You never go to the y-axis, always to the x, and then it forms a right triangle. Now, if you're using the idea of SOHCAHTOA, you can still get the same answers. But we would say since this point is x units over, this side is x. Since this point is y units up, we would say this side is y. Your hypotenuse here, we could figure out by going x squared plus y squared equals r squared, and then taking our square root. And that's what we're saying right here, and we're calling our hypotenuse r. So if you use the idea of SOHCAHTOA in the context of this right here, you get your opposite of y over your hypotenuse of r, you get sine. Cosine is adjacent of x over hypotenuse of r, and you get x over r for cosine. Or tangent being opposite of y over adjacent of x, you get y over x. And then, of course, you have the three reciprocal functions down here. Cosecant's reciprocal of sine, so you flip this upside down. Cotangents, the reciprocal of tangent, so you got to take your tangent and flip it upside down. Cosecant's the reciprocal of cosine, so you got to take this one here and flip it upside down. One thing I want you to be aware of is that we have three more theorems. They're called Pythagorean theorem identities, and they come from using the Pythagorean theorem on what we were just looking at with the unit circle. All three of these Pythagorean theorem identities will be on each one of your unit circle quizzes. You need to make sure you know each one of these. The first one is cosine squared plus sine squared equals 1. Next one is 1 plus cotangent squared equals cosecant squared. The last one is tangent squared plus 1 is equal to secant squared. Right now, I just want you to have these memorized, but we will be using them later in this chapter or unit. So let's go ahead then and find our 6 trigonometric functions in the context of this right here. So let's just, first of all, plot our point 8 units over, 15 units down. Your angle always comes from the origin and goes out to that point. Your angle then is always at the origin. Now you might think, well, there's two possibilities here. Well, let's go ahead and form our triangle. To form our triangle, we always go from here to the x-axis. So I'm going to bring this in. Now, this point, or this side right here, how far over do you have to go to get to this point? That's 8, so this side's 8. How far down do you have to go here? It's 15. The angle you're dealing with is always inside your triangle, and it's always at the origin. So the only angle that's in the triangle at the origin is this one right here. Now we could go 8 squared plus a negative 15 squared, and then take our square root to be able to figure out r, and we get r to be 17. So our hypotenuse here is 17. Now whether you use the definition from the previous page of x over r and y over r and all that, or opposite over adjacent, doesn't make a difference. Keeping in mind that since you're going horizontal, this is like your x if you're using the previous definition on the previous slide, and this is y and this is r. So for sine, opposite of negative 15 over hypotenuse of 17. Cosine, adjacent over hypotenuse. Tangent, opposite of negative 15 over adjacent of 8. Then you gotta have the three reciprocal functions, so you have cotangent, so flip that upside down. Secant, flip your cosine upside down. And cosecant, flip your sine upside down. Then we have quadrantal angles. Quadrantal angles are angles that end up being on your axes. So here's one of them, and that's 0 degrees. Here's another one that's on your axes, that's 90 degrees. Here's another one that's on your axis of 180. Here's another one that's on your axis of 270. And then it would be 360. And then 360 and 90 would be your 450, and so on. And it goes around and around at all these different ones. So, once again, there were 0, 90, 180, 270, 360, and so on, because they're all the angles that end up on your axes. Now, let's go ahead and find our 6 trigonometric functions for an angle or a point that is at 180 degrees. Well, I'll put this here. We don't necessarily know the coordinates of this, but we know we're going to the left, so we know our x-coordinate's negative. We're not going up and down, so we know our y-coordinate is positive. So we have our x being a negative r, our y being 0. Then you could go ahead and use the definition for r that we had right here of your x-coordinate squared plus your y-coordinate squared inside your square root. So we'll go our x-coordinate squared plus our y-coordinate. Here's your x-coordinate squared, your y-coordinate. You get 0 plus an r squared, so you get r squared. Square root of r squared is r. Now, sine, you can't use the idea of opposite and adjacent or hypotenuse for this one. You need to go back and use the idea of y over r. So it's your y-coordinate of 0 over your r. And so 0 over anything is 0. Or cosine is your x-coordinate, which is the negative r, over r, and you get negative 1. Or tangent, you know, is your y-coordinate of 0 over your x-coordinate of negative r. And 0 over anything is 0. Then you got to have your reciprocal functions. So here's your cotangent as a fraction. You flip that fraction upside down, you get negative r over 0, but remember you cannot divide by 0, so it would be undefined. Your secant. Here's your secant fraction that we get to flip upside down. Flip it upside down, we get this, and so we still get a negative 1. Your cosecant is the reciprocal of your fraction we have up here for sine. So you get y or r over 0, which is undefined. Let's talk about reference angles. Your reference angle is always an acute angle, meaning between 0 and 90 degrees, or if you're dealing with radians, it's always between 0 and 2 pi. So it's an acute angle, and it's always between the x-axis and the terminal side of your angle. So let's go ahead here and take a look at 160. Where's 160 going to be? Well, we start out here and we rotate to 160, and that's approximately over here. Now, it's between your x-axis and this angle, and it's always the smaller of the two. We really have this angle, or we have this one here, because they both go between the x-axis and your angle, but it's always the smaller of the two. This is your reference angle. We call it r, or theta with low subscript r. Now, what's the size of that? Well, that ends up being 20 degrees, because if this in blue is 160, you know if you go all the way around to your axes, this over to here is always 180. How far away are you from 180? Well, you're 20 units away. So let's go ahead and do the next one. You're at negative 110. Well, here's 0, This would then be negative 90. Negative means you got to rotate down like this. Negative 90, so you got to go a little past that to get to negative 110. So between here and the x-axis, it's either this one or it's this one here, but once again, it's always the smaller of the two. And so now that's our reference angle. We want to know how far are we from that x-axis. Well, we were at negative 90 here. We're 20 degrees into this quadrant, and so we would be 70 below that. Your reference angles are always positive because they're acute angles. Then we have a 275. 275 would start out here, rotate to 90, then to 180, then to 270, and just past that, and we would be 5 degrees past that. So your reference angles, you have a choice of being the orange one or the black one. And it's always the smaller of the two, and it ends up being the black one is the smaller of the two. So that's your reference angle. What's the size of that? Well, we knew we were just 5 degrees into your fourth quadrant, so this tiny sliver here is 5. But you know this tiny sliver in the black have to add up to 90 because it's a right angle here, so you end up getting 85. Then on our next one, we have negative 3 pi over 4. Negative 3 pi over 4. You're going to start here. You got to rotate down. This is negative 1/2. But we got to go to negative 3/4, it says, right? So negative 1/2 pi, we need to go to negative 3/4 pi, so that puts us over here. Then you need to go ahead and decide on your reference angle. Your reference angle would be here, so we get a reference angle to be here. However, we know if we go all the way back here, all the way around here, this is to a negative pi. But we only went 3/4 of the way, so that leaves us with 1/4 of a pi difference. So your reference angle is 1/4. So now we need to go ahead and find the exact values here. We need to go ahead and graph these. Negative 60 degrees. Our reference angle would be here, which is 60 degrees. Now, all we have to do is remember everything from the first quadrant. Cosine of 60 is one you're supposed to have memorized, so therefore you would put down 1/2. Now, thinking of what quadrant this is, and that cosine deals with x, you know it's going to be a positive 1/2. Then we'll look at the next one, 5 pi over 4. We go to 5 pi over 4, which is over here. Your reference angle then ends up being a pi over 4. Cosine of pi over 4 is the same as cosine of 45, which you're supposed to have memorized. What you get is being root 2 over 2. But since it's cosine and you're in the third quadrant, which is x, and x is negative there, you know you got to have a negative answer. Cotangent negative 150. Negative 150 starts here, rotates down, puts you over here. Cotangent, or your reference angle then would be 30 degrees because you're 30 below your axis. Cotangent of 30. Well, you're supposed to have the tangent of 30 memorized, or you're supposed to have the sine over cosine memorized. And so then you end up getting root 3. Now, if you did it this way, you know the cosine of 30 is root 3 over 2. Sine of 30 is 1/2. You have a fraction on top divided by a fraction, so you multiply by the reciprocal of the bottom. The 2's drop, leaving you with just a root 3. And in this case, both the sine and cosine are negative, leaving you with a positive answer. Then over here we go to our angle. Our reference angle then is going to be pi over 3. So we got to look at the cosine of pi over 3 because that's reciprocal of our cosecant. So we get 1 over the square root of 3 over 2. And it's negative because your cosine in this quadrant is negative. So now you have a fraction of 1 divided by a fraction. So you multiply by the reciprocal, but now you have a root in the bottom, so you have to rationalize that. Multiply the top and the bottom by root 3. So now you multiply the top, you get a negative 2 root 3. Multiply the bottom, you get a 3.